This is how we start a program in C, program in Keel, when we start with C programming. Because by default it has included stdio.h. By default it is there already. I don't need to include it now. Keel has taken care of that. Now I have to include what I require. I require res 51, so I have written that res 51. You know what is res 51 now? You know what is res 51? That the explanation was clear. Right. What should I do? Void main. Void main like here because this program is a part of the another program inside the Keel. Okay. We'll gradually understand it. Right now you believe like this is the syntax. Void main, void is the syntax. Neither it is receiving any value. Even in for so what is this? For loop I have closed. I have to close the main loop. What is that we are doing? Infinite times we are giving a value for port 1 as 55. Sorry, not FF, AA. Sorry. AA. 55 and AA are complementary to each other. One's complement of the number. ತುಂಬಾ ಖುಷಿಯಾಗಿದೆಯಲ್ಲ ಏನು ಏನಿಲ್ಲ right. Oh, you guys are sitting together. Okay. That's why you are happy. You are knowing that? Don't know. They see they are sitting together. All of you see there. Last time when we discussed about them, like we thought that like they got divorced, right? So now I can see. Oh, this guy. Oh, okay. I got confused with them. Okay. So you found new one. Right, guys, listen. Yeah. For port 1, it puts 55 and then it puts AA. So those 55 is what number? 0, 1, 0, 1, 0, 1, 0, 1. So these pins, they will connect LEDs and check like they will glow. In the next cycle, the reverse, 1, 0, 1, 0, sorry. Correct, 1, 0, 1, 0. The reverse pin will glow. All the LEDs will be connected. They will write this program and check whether that pin is going up or down. Yes or no. Is it clear? That's all the program. Put a controller, dump a program, press a reset, pins are going up and down, then it is gone. Next controller. This is how they check the pin of every port is working. Like that you can write it for others also. Okay? Right? Done? Is it simple program now? In C it is only this. Okay? Hitesh, you have a doubt? Yeah, Hitesh, you don't have a doubt? His question is delay. Without delay, how can we see the result? For that, you should write a function. Shall we write it now? Like, you know, all of you are familiar with the functions. Harshit is familiar with the function. How to write a function in C? Bharat should tell you yes. Bharat, sit properly. Lenience does not mean like you should cross your freedom of speech. All of you are understanding what I am speaking. Did you got what I am saying? You know what is last 20 days or something like what is going on the news? Freedom of speech does not mean you should forget your basic responsibility towards the society. Okay? And that you should carry this responsibility, you should carry in every relation. Not only with the nation or with the society. Okay? In your father and son, father and daughter, mother and daughter, there is equal responsibility and equal freedom is there. Where in other relation it is not that much. But there is a responsibility. You cannot speak like anything that you want to your father or your mother. Correct? That also has certain responsibility. So, same case. When we give a lenience, some laughing in this is required to some extent if my mood is good. Not on your mood. But not to the extent that you take a liberty that like, do anything that you want. Not accepted. Okay? Some of you have understood right what I am speaking. Generally and particularly both. Right. Guys here. Do you know how to write a program in C? Oh, sorry. Function in C. We will quickly take one example and write for this. How do we write a function in C? Right. What is that? First thing what we have to do when we write a function in C? When we write a function in C, what is the first step? Prototype. Prototype of a function. Where do we do it? Before the void main. Here. Here I have to write this thing. What I will write now is void m underscore delay. M underscore delay. Unsigned char. Please write this. Void m underscore delay. Unsigned char. That is a function prototype here. Next, what I have to do in a program? Program here. Somewhere I have to declare this unsigned char. A. Unsigned char A. One variable I have declared. This O. This A is not accumulator now. Accumulator is gone. This A is not accumulator. Okay? If you are confusing, write BMS. If it is confusing, write BMS. Okay? Right. Next, what do you do? M underscore delay. M underscore delay. Now, whatever the value you want to give to BMS, you give it. You want a delay of 0xFF. Can give it, or like decimal we can give it easily. 255 we can give. No. This is only right. 0xFF. Now M call delay A. We have not yet written the program, full program. Wait till that, then it will be clear. I have called a delay here, I will also call a delay here. M call delay. Done. Now you should write on program. What the function? What is the function that you should write? Void M underscore delay. In here it is full, right? Unsigned char BMS we should write. Full I have to write. Here it is only type of the variable. Here I should write the type with the variable. Okay. I can declare something else also here, right? So that we'll catch it here. Yeah. Right now we'll say BMS1. BMS1. What you do in this? What you do inside this? How much ever delay you want to create, you create now. For loops, or like before this, we'll include one more thing. unsigned int I for I equal to 0, I less than unsigned int, right? I can go to any value, ff, I less than or equal to ff, I plus plus. Okay? What I have to do here? Nothing I have to do. So simply I am wasting time here. For BMS is a value there. BMS, what should I do? The BMS again and then like decrease it. No, we have a BMS of value here. For I equal to this. Huh? No, BMS is a value that I have to use here. Huh? 16 bit. Unsigned int I is 16 bit. In here for BMS already has a value. So what I have to do? BMS J equal to BMS. I can write BMS directly here. Why? Like this. J equal to BMS 1. Then like J minus. No. J less than. No, J greater than 0. J minus. Correct? Is it right? J equal to BMS 1. Thank you. Feeling well? Yeah, very good. Even I was also not feeling well. Once I come to class, it is all right. Sorry, I will take. Thank you. See, your madam is not feeling well. Vidya madam, she is not feeling well. So we'll continue. Okay? Good enough. Good one. Don't want. Me, if you say don't want also, I will do it. Simply I ask you. She called me in the morning itself. I felt like even I am not feeling well. Let's not take it. Then once I come to class, I am all right now. Right, listen. What I tried doing here is this. I tried controlling the delay. I'm trying to control the amount of delay through a variable BMS. Okay. Whatever the value I will give here, that is the delay controlling loop or delay controlling variable. This whole loop will generate a delay. How much delay that has to be generated will control through this variable. You give only one to this will run in a shorter duration. You give FF, it will take some more time. Because it is FF into BMS 1. How many times this loop runs? FF, 4 times F into BMS 1. If you want to run it once, it will run FF times, 4F times. If you give it 2 here, it will run 2 into so much of time. You are understanding this? Now inside this, if you check it, this uses DJNZ only. To do the for loop implementation, it uses DJNZ only. Okay. Balaji. Sir, antilla, yen kelud nanige. Here, I have one. Ide bidu. Is it clear? Slight confusion has happened while writing it, but is it clear now? Shall we once again try to understand it? Guys, listen now. Don't write anybody who is writing, please stop here and listen to me. Chetan. Reg 51, you know why it is required. Void mean void. Neither I am receiving any inputs to the main function, nor I am giving any output from the main function. This is return type, this is argument type, correct? Before this, in the global declaration, I should declare a prototype of a function if I am using a function. This is standard rule from the C. Or otherwise there is one more way. What is the way? Write function here. Write function here, then you don't need to declare a prototype. If you are writing a function after the main, then you should declare a prototype. Every function has three stages. One, prototype, function call, function definition. So this is a function prototype. Then this is a function call. mDelay is a function call. This is a function definition. What it has to do, we have defined it here. This is we are calling. We are just saying it is there. In this, it is there with this thing. It will not return anything, but it will take one argument. Clear? Right? Done. Next one. Unsigned char BMS. We know that unsigned char will vary from 0 to 55. That's why we have given the value FF. Right? Then for loop, this is what for loop. This is an infinite for loop. Neither any argument is there, the for loop I value is there, or neither it goes to maximum value or this. This is called infinite loop. You can also write while one for this. Same thing. P1 equal to 55. You know what is P1 equal to 55. We have discussed. mDelay BMS. When I do this, it will go here. Now, in assembly. L call. What happening now here is an L call. Right? In L call, when we come here, we'll write a subroutine. We have written the same thing in this also, but only thing we have not passed an argument there. We are trying to pass an argument. Okay? Right? So in here, once we come here, it is unsigned char BMS1. The BMS1 will be equal to BMS now. This is the argument passing, this is the argument catching. Catching argument is this. They have to be of same data type. They have to be of same data type. Otherwise it will not receive here. This is, actually it is called as argument throwing, and this is catching, right? This throws an argument. This function call throws an argument BMS. The function definition catches an argument BMS1. Same BMS value it will throw here, it will receive in BMS1. Both of this throwing and catching should be. Then unsigned int I and j. We have declared two unsigned int values, for which unsigned int, this is a for loop. I equal to 0. It should go when it is below FFFF, I++. Till below FFF, it should run. When it will be more than FFFF or equal to Kotidivala, okay, then it will run. You're understanding? It will always be below FF only. When it will go above FFF. Less than FF, I will reach maximum value of 4F that you have given I less than or equal to. Correct them. Okay. Then for j equal to BMS1, whatever the BMS1 value you have given, here it is FF 255. J greater than 0, j minus minus. Right? Once this for loops calls this will run for so many times. In this case, it will run for 255 times. And then it will go here. It will reduce FF2, it will increment 0 to 1 and then call it again here. That is why the delay value is F into BMS. Total delay of this loop is that. This we have done in the same calculation we have done in the assembly language. Is it clear? Once this is done, we are very clear, once it is done, it will come out here. It does not return anything. So it will come back to here directly. What is this? Come back here means what? RET, return. This is L call, mDelay. From there it is coming back means there is a return by default. So it came back here. How it came back here? How it comes back to only this position? Huh? Which value? How will it come to the only this instruction? Why will not it go to this instruction? Huh? PC points to next instruction. Next instruction is here. PC was here. If this program is executing means PC is here. Right? One second. PC is here. Now, like PC has to get the value of this one. How it will understand it has to go here? Balaji, I have told you. Anybody else? What happens when L call is executed? What happens when L call executes? L call, guys, listen to this very carefully. If this is a L call here, it will go to this instruction to execute. Right? PC will change from this sequential values to suddenly some value wherever this instruction is stored. Right? But before going this, it will store this PC value, this instruction PC value on the stack. Did I discuss on this? Yeah. Then that is called as bookmarking the sequence. It marks here. It will keep a bookmark here and then it will go here, refer it and come back here. You're understanding? This going and referring it here is that. Is it clear? So this instruction value is stored in a stack. It goes here, changes the PC value. Goes here in the sense what? PC value is this value. Finishes the execution, comes back. What is the meaning of comes back? It retrieves the data from stack. PC value, whichever ever has been stored to the stack, it will get back that value. Then this instruction will start executing. That you should make sure. See, I will tell you the secret of the C program. Every bracket does some push and pop. This is push and this is pop. This has to be equal. Then you will throw error if you don't do that. One side. The other side, if you are intentionally doing some push value here, that means you are writing a program. It is your responsibility. If you push it here and don't pop it, then you try. It will go to somewhere else. Whatever you push, you should pop in the function. Otherwise, you are disturbing your program flow by yourself. You can try this. Okay? Right. No, I didn't get you. What is it? It is unsigned, right? It is 0 to FFFF. If you increment, it will be 0 again. No, that is equal to, right? If it is equal to there, then it will come back. If I is equal to or less than. I is 0, I is less than or equal to FFFF, I plus plus. If I is less than FFFF, then like this should, oh, okay. Right. Done. Is it right, madam? Correct, sorry. Jako, in center of attention, when you want. Right, is that clear now? Any doubt in this? Right, we'll write one more program quickly. What is the program? The same program, okay, I will tell you the statement, you write the program. Write a C program, write a C program, write a C program for a doorbell. For a doorbell. What is this program? What is this program? Same yesterday's buzzer program which you have written in assembly, now you have to write in C. Can you try? Can you try? Give a try. What do you have to do? What do you have to do? Define bit for it. How do you define? I will tell you that. That one statement I will tell you. See guys here, listen. Bit A underscore 4 equal to port 1 first pin. There we used to write P1.1. Here P1 cap 1. That is the difference. That means port 1 first pin is named as A underscore 4. Right? Now you know what to do. While A underscore 4, you do something because it is a bit value. One more thing that what you have to understand is, whatever we discuss in the class or whatever we analyze logically, it is whatever we analyze, it is pure logical process. Logically it might be right. Experimentally, on that hardware, that software when you use, there might be some changes. For example, like end. Logically we said like it is end has to be here, accepted. But when we say like goes with the directive, is that clear? Logically it is right, whatever we have discussed. So some this clear. That is where there is a lab is linked. Quickly, write on small program. Oh, hold on, listen. You've done one small mistake. What is that? I have done one small mistake. Not in this program, only in this. It has to be S bit, not bit. Bit is for RAM. S bit is for SFR. This is the SFR value. This is SFR value. Which SFR? SFR, just SFR. Then you are using whole port. Bit, if you are using a one, yes. Then P1 only. SFR A underscore 4 equal to P1. No, byte. We have written that, right? 8 bit. SFR is 8 bit. How's that? Byte addressable or bit addressable? Whether the memory is byte addressable or bit addressable, you can use SFR. P1 is what? P1 is a byte addressable memory and also bit addressable memory. For that you can use SFR. Guys, listen. This confusion is there for everybody. SFR, you can write SFR A underscore 4 P1. Right? The SFR is 8 bit value. S bit is 1 bit value. Right? The difference is SFR can address the byte addressable register or bit addressable register. But S bit works only with bit addressable register. Did you got my point? Is that clear? Right? Please do that. Huh? Yeah. While a and square 4. That's all. No 0 checking. Why you need? It is by default. It is while a and square 4 equal to 1. Is meaning that a is equal. Just writing a and square 4. That's all. Very simple program. Very simple program. But you should write it in for loop. This infinite loop. Guys, Jyoti, the structure for this program is yesterday's pin diagram that we have given. For one pin we have connected the switch, the other pin we have connected the buzzer. You were there in yesterday's class. Did you wrote that diagram? Inne bandila. Yake? That means your responsibility is double to understand. Guys, listen. Done with the discussion. You want a discussion? Anyway, extra class, right? Then we don't know C programming. This is also S-bit, madam. Both are S-bit only. ಯಾಕೋ ಮೌಸ್ ಇಟ್ಕೊಂಡಿದೀಯ ಅಲ್ಲಿ ಏನ್ ಮಾಡಿದೆ ತೋರ್ಸು ಹಿಂದಿನ ಪೇಜು ಟರ್ನ್ ಮಾಡ್ತೇವೆ ಮಾಡು if a equal to what is this 0 na so bit value right
I think as input pin 11 is equal to 1 A4 is equal to 1 that is capital
pin 11
pin 11 is my
port 1 okay that if you make it 1
make it 1 so that will become input yeah that's it
you can do okay by default also it is input only no require initially you can do then like it is 1 else it is 0 that's all for the else it will be on always it will be off always into your reverse right reverse logic guys listen done ಬಂದೆ ಮಗನೆ ಬಂದೆ ಏನು ಬರೆದ್ರು ಬರ್ದಿಯಾ ಬರ್ದೇನಾ yesterday we have hello now listen done enough discussion is done like listen to me yesterday we have said like we don't need a delay for this program right you have to test that logically you don't require a delay experimentally you should test and prove it okay right so what I do is I will erase this delay and we require this will write one systematic program here. Yeah. Now listen, no talking. Yes, bit. Let's take one. What is the? Yeah, this is good. Pin 1 1 is equal to port 1 pin 1. Said no talking. Yes, bit. Pin, what we do? Some other port. What we have taken? Second port. 2 3 is port second third pin. Let's assign this to the value. Or like you can do one more thing. This is a doorbell, right? You can write doorbell here. That is easiest way. When doorbell, that is the easiest way to write in English statement. Right? This is a buzzer. Buzzer on or off you can do it. Right. Once it is there, then next wide main. Wide. Writing in the main loop. Jannavi, no talking. What we have to write now? In the main function, what should I write? First, I have to write infinite loop. Keep in mind, without infinite loop, it will check only once. The whole program executes in some microsecond. Before you thinking of switching a press, the program is done. Reading what? Your logic is right, but if you have to write it in infinite loop, for that, like you should use that for in this, inside this, you should use if or while or like the whatever the condition you use. If or pin and 1 1. Pin 1 1. That means when it is pressed, what I have to do? Pin 2 3. 0. That's all. Right? Right? Correct? Will this work? Hold on. Will this work? Will not work? Huh? Why it will not work? Yeah, that is why we have made that as 0 now. It is 0, then why it is buzzer is on? Right? Guys, listen. Hello? Perfect. Once you press it, once you press the switch, now you should understand this program with respect to hardware. Link hardware and software now. Once you press a switch, this will enter the loop, otherwise it will not enter the loop. P11 will become 1 that at that time when you press a switch. It will become 0. So when you don't press a switch, it will be inside this loop. Then it has to be 1 here. According to this was a structure. This was a structure. When I press a switch, it will become 0. Right? When it becomes 0, then I have to do this. So what I have to do? One, I have to write the concept as while not of pin 11. Easiest way is this. Not of pin 11 means when it is 0. When it is 0, then do this as 0. Shall we make it simple? Why are we making that negative in this thing here? No. This is simple, right? Or like you can short it also, not suggested, but like theoretically you can short it. No. Correct. So when there is no voltage, it will be at almost equal to the ground. When I press this switch, the VCC will be here, dropped across this resistor. That is the point, right? So when I press the switch, this will become 1. And when it is 1, I should make this as 1 to buzzer, beep the buzzer, right? This is a simple concept. We'll do with this. So when I press a switch, P11 will become high. When I press this switch, this P11 will become high. When it is high, the P23 should also become high when the buzzer is on. First we should initialize it to 0 and then like we should take it. What is it? Anyway, we should also find a solution to this. If else is another solution, like if his option is this, else his option is this. While you tell me the solution, what I have to do in here is like first P2.3 I should make 0. Initialize it to 0 here only. Once it is 0, then like while 1, if the switch is pressed, then it will become 1. The buzzer goes on. If the buzzer goes on, till the switch is pressed, it will be on. Once switch is not pressed, it will become, it will still be 1. That means you have to do it outside the while loop, inside the for loop. Outside the while loop, inside the for loop. Where should I do? Before while we will write it. Pin 23 equals to 0. Now it will work. Did you got this? Shall we repeat? Please listen, all of you, don't write. What we have done is, this you understood. These two you understood. Pin 1.4 to 1. First pin is assigned to one variable, pin 11. Port 2, third pin is assigned to another variable, P23. You can use anything here. BMS, Bangalore, anything here. Wide, main, wide. Neither it is returning nor it is taking any value. For nothing here, it is an infinite loop. Pin 23 is made as 0. Why? Cleaning. Pin 23 is made as 0. Why? By default, pin 23 carries 1 as a value. That you should remember. While writing a program, even I was not remembering. Right? So pin 23 you have to make it 0. That 23 you have to make it 0. While pin 11, that is port 1 first pin is 1. Only when it is 1, while 1 you know this concept, this funda, right? Only when it becomes 1 it goes inside. If you want you can put double equal to 1. That is also okay. Double equal to 1 and then like it does P23 equal to 1. P23 is this connected to buzzer. Then it will make this as pin as 1. Then like this will happen. This will run. When till your program, you are holding the switch. You are holding a switch, it will enter the while loop and do this. If you leave the switch, what happens? It will not enter this loop. It will just be P23 0. This infinite loop. That 0 means this is 0, this is 0 grounded, so it is not biased. It is properly to the 0. Is it clear? So now some of you have to do the self-study, right? In that, my wish is that you should start with this program. You should start with this program. Test one LED, test one buzzer, check whether it is working on that pin. Then you go ahead with the next year program. All of you should do this. Right? Pin 2, 3 equal to? Can be made, I believe. Pin 2, 3 equal to pin 1, 1. This is by default as an input pin. The input pin is given to 2, 3 as an output pin. Can be made. See, her point is that it's a good, right? Correct. Even why do we check whether it has gone 1? It has become 1. Super. See, what is Divya's suggestion is that Divya Guruswamy, correct, right? I like your full name. Pin 1, 2, 3 equal to pin 1, 1. That's all. Whenever I press it here, it has. By default, it is a so. Remove this controller, connect this here. You are getting what is it? When you press a switch, it will go make this as high and then like that buzzer will go on. Good. For infinite loop P23, P23 is equal to P11. That's all. Why do we think so complex procedures? Very good. Thank you. Yes. By default, it is the input port. That is the assumption. That is the assumption that we have to go ahead with. Somewhere you have to make, the easiest way to make is to CLR this thing. Make it as P23 0 before this for loop then. What we do is we'll write this, please test it. What we are discussing is all logical. Experimental should be something else according to the software and hardware. According to the logic, whatever we discuss. Even why is this required? Because my experience in this also is less. If I would have had an experience of DEC, I would have told you very clearly this is what is going to happen. Right? So that is a disadvantage. You have to learn. Bear with a non-experienced teacher. Pin 2, 3 equal to 0. First you make 0 so that like it will become output port. Right? Done? Done? Right. Quickly what we do is we'll yeah? Enough? Yeah. Write on homework. Write one homework. Write 8051C program. Write 8051C program to send values from +4 to -4 on port 1. On port 1. How do we do it? You understood the program? There is a port 1. Guys, listen now. This is a homework, you do it in homework. Then we'll close it. Start yours. Port 1 should be declared as an output port. Once it is an output port, you should start sending some value to that. What are the values? You should start from +4, +3, +2, +1, 0, -1, -2, -3, -4. These values you should send it on the port, this thing. But how do you go with minus the value? Signed in or signed char. Signed char or signed in. Oh, this is one aspect. The other aspect, you should be very, very clear that machine does only the things in hex. Int, char, or like the bit and all these things. It is only for you guys. You feel char is A. The machine knows that char is hex value. A is hex value. Everything is just a number represented in hexadecimal. That you should keep in mind. Char A, if it is character A, it is for you as in capital A or small a. For machine, what is the number? What it is the value? Some number in ASCII. Always it is some number in ASCII. Signed, some number in ASCII. Unsigned, some number in ASCII. Plus value, some number in ASCII. Sorry, some number. Minus some number in the... Everything is some number there. There is nothing called as plus, minus, character, integer, float value, nothing. Dot, nothing. Just some number in hexadecimal representation. Okay? That is where you can use unsigned char as a counter value. Last example I have given. If you try to do it in the normal C program, it will throw you an error. By saying that like char plus plus will work. That does not will happen. That will not happen. But in here it is possible because that is treated as a number directly. Is it clear? Is it clear? Right? So will you mention that point? Please mention that point at the end. There can be floating value, you can create it. As if a controller, that will not support floating value. But you can do some maths and do it. Header you can create it, that's what I am saying. These are all software, right? You can write one program and like make that as header file. The machine works only in the hex value or hex number. Hex value or hex number is same. Machine works only in hex numbers. Plus, minus, character, special character, should write all these things. Plus, minus, character, special character, or a number. Number, alphanumeric, right? Numeric value, or a numeric value. The machine internally takes only hex numbers. Machine internally takes only hex numbers. Is it clear? The statement is clear. Now, close your all books. I will stop here. Before winding it up, like I have to discuss 2 points. One, till now, you remember initial days, like we started with architecture, you had some, I can call it as a illusion, or now it is a disillusion. The point is, you had some points wherein which it is not going with a very clarity. There is no 100% clarity. Now is it clear? Now is it clear? All of you are comfortable with architecture. You should, whatever you do, architecture should be at the back of your head. You should link with that. Doing that is the first point. Second point, this is the first point, B is this one, not second point. What we are doing is, we have studied everything now, including ports we have covered. Ports, all the registers, all the RAM, ROM, and the ALU, we have covered everything now. So we know how we know how to handle the internal part, that is only the data movement part, or addition, calculation, and storing the value. We also know how to send the value to the output, on the output ports now, or take the value from the ports now. We know till here. What is that we are missing? Still, is there anything that we are missing? In the ports, if we discuss in general, whatever we have done like switch and the buzzer, the general discussion of port being an input port or input pin or output pin. How do we make that pin as a time